Welcome to Let's Talk Micro. Hello, everyone. Welcome to another episode of Let's Talk Micro. I hope you had a great week. So, like always, before we get started, let's remember that Let's Talk Micro is available on Apple Podcasts, Amazon Music, Spotify, Google Podcasts, Stitcher, TuneIn Radio, Overcast, Pandora. Wherever you listen to your podcast, you can listen to Let's Talk Micro. I am also on Instagram as Let's Talk Micro, no apostrophe, and on Twitter as Let's Talk Micro 1. So go ahead and follow, please. So on the last episode, we talked about the triple sugar iron test, or the TSI. As you remember, this test is used to determine whether a gram-negative rod ferments glucose and lactose or sucrose and forms hydrogen sulfide. So it has phenol red as an indicator of acid production, and it has ferrous sulfate as an indicator of hydrogen sulfide production, or H2S. And just to recap a little bit, so this test, when I said gram-negative rods, it is used to differentiate the Enterobacteriales from other gram-negative rods. So not just any gram-negative rods, your Enterobacteriales, or as they used to be known, Enterobacteriaceae. As you remember, it has two parts. So it's an agar that's slanted. So it has the slant, which is the tilted portion, and it has the butt, which is the bottom portion. And when you read them, you read it slant over butt. And then we also talked about what color changes there are, what do those mean, and what reactions do some of these Enterobacteriales they have. So like as I mentioned before, phenol red is an indicator of acid production. So when glucose, lactose, and sucrose, they're fermented, acid is produced that lowers the pH. And then the medium changes from red to yellow. That's why when I was talking about the reactions on the last episode, if there's no color change, it's called alkaline. So that's one of the terms that we use, alkaline and acid. So we use the letter A for acid, we use K for alkaline. And you read it slant over butt. So if an organism ferments glucose, the butt turns yellow. If the organism ferments glucose, lactose, and sucrose, the butt and the slant turn yellow. If hydrogen sulfide is produced, the agar looks black. And then if there's gas produced, we have bubbles or cracks on the agar. So like I said, we read it slant over butt. So if we have an alkaline slant and no change on the butt, so that will be K over K. This means that the organism does not ferment glucose, sucrose, and lactose. If we have an alkaline slant and an acid butt, K over A, the organism ferments glucose only. And then we have an acid slant and an acid butt. The organism ferments glucose, lactose, and or sucrose. A black precipitate on the butt, hydrogen sulfide production. And then gas, like I said, bubbles or cracks in the agar. And then we went over the results, some of the results. So for E. coli, you can have K over A over A, or K over A with gas. Klebsiella pneumoniae, A over A with gas. Salmonella, K over A with gas and H2S. And I went over to mention the result for Pseudomonas aeruginosa, which of course, is not an Enterobacteriale. Just by the oxidase alone, it's oxidase positive. You will rule it out. But it's also used as a control when you are testing this medium. Include your Pseudomonas aeruginosa because it's a non-fermenter. It's not part of this group. And you can see what a true negative looks like. So it's good to remember that. So that was a good recap. And of course, if you want to once again listen more, go ahead and go back to the previous episode where I explain it in a little more detail. So it is great information to have. I keep saying this test, even though maybe if you're a tech in the US, you might not use it, but it's definitely good to know about it. You will be tested about it when you take your licensing boards, like American Society for Clinical Pathology, ASCP. And if you're a listener from another part of the world, then you know that you use it in your lab. So it's kind of great to correlate all this information. So it's a very important test used to differentiate Enterobacterales from other gram-negative runs. So on today's episode, I want to talk about the LIA test. So what's LIA? That's called the Lysine iron agar. And this is used to differentiate gram-negative runs based on the decarboxylation or deamination of lysine and the formation of hydrogen sulfide. So that brings the question, what is lysine? With some definitions I get technical. So lysine is an amino acid that is used in the synthesis of proteins. As all of you know, we definitely need proteins in our bodies, for them to properly function. So lysine is one of those building blocks of protein. And it has an amino group, a carboxylic acid group, and a side chain lysyl. But I'm not an organic chem major. I'm just a clinical microbiologist. So if you want to study more lysine in detail, go ahead and refer to some of the organic chemistry textbooks. So this is the basic definition of what lysine is. This test has similarities to the TSI triple sugar iron test. And as I go over in this episode, I'll be talking about them. So this medium, just like the TSI test, it's an agar that's slanted, but the TSI, it's a red in color, the initial color. For the LIA, it's purple. So it contains lysine, peptones, glucose, ferric ammonium citrate, and sodium thiosulfate. Also, just like the TSI, it has a slant and a butt. And just like TSI, it has glucose on the butt. So if the organism is a glucose fermenter, it's going to turn yellow. So opposed to the TSI, where your phenol red was your pH indicator, in this case we have bromocresol purple as a pH indicator. So when acid is produced, the medium will go from purple to yellow. So even though we have two different indicators, the end color is the same, and TSI as in LIA, we have a yellow color when there is fermentation, which produces acid lowering the pH. So phenol red for TSI, bromocresol purple for LIA. So different indicators, but the same color change. However, there's a difference here, because even though, yes, if the organism is a glucose fermenter and the butt turns yellow, like I mentioned, this test is used for, it looks for the decarboxylation and deamination of lysine. So in this medium, decarboxylation occurs in the butt. So if the organism produces decarboxylase, which is going to decarboxylate the lysine, then there's a product that's formed, which is called cadaverin. And this is going to cause the butt to turn back into purple. So here's the change. If the organism is a glucose fermenter, it turns to yellow, but then if it decarboxylates lysine and cadaverin is produced, then it goes back to purple. So that means that if you end up with a yellow butt, the organism is a glucose fermenter, but does not decarboxylate lysine. So that's definitely a change that we have between the TSI and the LIA. And of course, I'm kind of comparing and contrasting. I mean, these tests, they have different purposes. But as we go on, and I'm talking about this is good to paint. If you're a visual person, I keep talking about the reactions and what they're similar, so you can follow along. So the carboxylation occurs in the butt, but deamination occurs in the slant. So if deamination occurs, there's a compound form that in the presence of ferric ammonium citrate, it will change the slant to a burgundy color. So not yellow, not purple, but burgundy. If H2S is produced, a black color is observed in the slant. So you're thinking about how do you inoculate this test? Well, you will do the same as you would do the TSI. And I mentioned that method, so it's easy to remember. Stab and streak. You stab the butt, and then as you pull your loop or your needle, you streak your slant. So it's a very easy procedure. And then you will incubate it from 18 to 24 hours. And then you observe your reactions. So you read the same, slant over butt. So if you have an alkaline slant and an alkaline butt, and just like the TSI, we use the same terms, A for acid, K for alkaline. So if you have an alkaline slant and an alkaline butt, both are purple, the organism decarboxylates lysine. If you have an alkaline slant and an acid butt, the organism ferments glucose, right? Because acid, yellow. And if you have a red slant and an acid butt, the organism deaminates lysine and ferments glucose. So we're using the term K, like I said, for alkaline when there's no color change, and A for acid when there's color change to yellow. So some reactions here, we have E. coli, which is K over K, Citrobacter frundi, K over K with H2S, Proteus mirabilis, red slant and acid butt, which is reported as R over A, and then Salmonella species, K over K with H2S. And as I mentioned before on the previous episode, and then I will go ahead and mention it on this one as well, I want you to remember the term space for H2S production. I didn't come up with it. So Salmonella, Proteus, Arizona, which is now Salmonella, which is a subspecies of Salmonella, Citrobacter, and Edwardsiella. So these are Enterobacteriales that are H2S producers. And as I was going through my textbook to get more information, for this test, Proteus species that produce H2S, they will not turn the medium black. So you will actually need to do another method of testing to identify them. So let's go ahead and recap once again. So LIA, we use it for the, differentiate between gram-negative rods that decarboxylate and deaminate lysine. So a major change from this to the TSI, which is that you can have a glucose fermenter that will turn the medium yellow. However, if it decarboxylates lysine, cadaverine is produced, and this will change the medium back to purple. And that's why when I was going over the reactions, if you saw that E. coli, it said K over K. Well, E. coli it's a glucose fermenter. However, in this case, it decarboxylates lysine as well. So you're gonna end up with an alkaline butt. And that, my dear audience, is the end of this episode. I hope you enjoy listening about the LIA or lysine iron agar test. I sure enjoyed talking about it. As you notice, this episode is a little bit shorter than others. I'm just giving you a little bit of a break. I've been giving a lot of information every week, so we're gonna keep it short. But you know what we're not keeping short? Our motivation, our passion. Bring as much of that as you can to your workspace, to your life. Continue that motivation. Continue staying safe. Please, we have seen those COVID numbers as they keep going up. So please go ahead and stay safe. Continue staying motivated. And of course, continue talking micro. I hope you have a great week, and until next time.